All right, so the next topic is the programming environment, or the IDE. So we need a programming environment. So what is an IDE? That's the big question for the moment. So we need a programming environment, all right, to do programming, basically. Right. So in a programming environment, it contains a certain number of tools. So essentially, a programming environment contains a number of software tools that are essential for program development. Okay. Previously, in the early days of computing technology, all of these tools separately were used, so they were not so convenient. Now, as software development advances in software development progressed, they started to produce software programs that were a collection of all of the tools were available from one single environment, and that environment is known as the IDE. So it stands for Integrated Development Environment. So it's a development environment, so it helps us develop the program, execute it, and check it out result, and if there are problems with it, debug it. And it's called integrated because it gives us access to so many different tools that we need right from one user interface. So it's basically okay. So it allows us access to different software tools, which tools means programs, from one user interface. So we don't have to do like close one program and go to another one, or minimize the other and then do something else with the other one, call another one. No, right from one interface, everything there is available. What are the tools that we actually need? And so that's the question. So let's look at those. So IDE consists of some of the essential tools. So the very first tool that we need is called an editor. All right. And that editor is actually an ASCII editor. So it let us type in text that is saved as an ASCII file, and that ASCII file can later on be read by that interpreter or compiler, whatever language we are doing, and then it could be converted to machine language. So it has to be ASCII, which is basically another name for saying it's a text file. It's a text editor. Okay. An example of is Notepad, the very simple text editor, ASCII text editor that comes with Windows. So it's the most simplest that exists, and I don't like it very much, but it's a perfect example of an ASCII text editor. An example of, so this is ASCII, or we can also call it text. So whenever we say text editor, it means ASCII editor, or ASCII editor means text editor. An example of something that is not an ASCII editor or text editor is MS Word. It's not an ASCII or text editor. It's actually a word processor. It is a word processor. All right. So it has a word processor can include in it lots of different objects, like not just text, but it can have images as well. It can have spreadsheets in there as well, right? Which is not text. So a text editor just simply cannot display images or anything else other than simple text. So that's one of the big difference. So you cannot use MS Word to type in your code of Python or something else. If you do, you have to make sure you select, well, the docx format is not a text format. If you do type your code in MS Word, first of all, it's not a good idea. Then you have to make sure you save it as a TXT file or as an ASCII file. It has the ability to save it as an ASCII file, but in general, it is not meant for it. So there are special purpose editors. So simple editors are needed, and then so that is an essential tool. As we progressed further, software development progressed further, they started to make editors that can actually recognize the syntax or grammar of a language and display different parts of the language in different colors. For example, comments are displayed in a different color. Keywords, which are words that are reserved for a language, are displayed in a different color. Modules that the users make are displayed in different colors. Variables declared displayed in different colors, and so on and so forth. Such editors are known as syntax editors. Right? So anytime you see an editor displaying text, displaying your code, any programming language code in different colors, most likely it is a syntax editor. So a syntax editor is one, it knows the grammar, or which is also known as the syntax of a particular language. Right? So it can display different elements of the language in different colors for the program, for the convenience of the programmer. So almost all the editors that almost all the IDEs that we have for different languages, they have what is known as a syntax editor in them. All right, so what other tool do we need? We need either an interpreter or a compiler, depending on the type of language you're using. So the IDE allows us to give us editor, so we can type in the code, and then it has many options or buttons that let us, when we click on it, it runs the program. If it directly runs the program, then it's definitely using an interpreter, some kind of thing. Or it allows us an option to build a program, compile it, and then run it, something like that. Based on what kind of language you're using, it's either an interpreter option is there or a compiler option is there. Sometimes it doesn't have to be the interpreter or the compiler or the translator. It doesn't have to be built into the IDE, but it has to be there on your machine. So sometimes you have to install it, the interpreter or the compiler, separately, and then you need to tell the IDE where it is, the path of it, and then the IDE calls itself, feeds it the program, gets the translated program, and show you the results. The other thing we need that is very, very important is called a debugger. When you write in program, most often than not, you make mistakes in there. So there are two types of mistakes. One is called, so let me go to the other one. So, right. Types of errors in code. So there are two types of errors. One is called the syntax error. All right, syntax errors. These are the ones that are, these are the mistakes in the grammar of the program. So you mistype something. You mistype the code. Sometimes you make deliberate sometimes you make mistakes by mistyping. Sometimes you do not know how something is written. All right, and so these are generally, these are always caught by the translator. right? Which is either the interpreter or the compiler. So it will not translate the code if it finds there are some syntax mistakes or grammatical mistakes in the program. It's going to stop and let you know the line number where it thinks there are some problems. Sometimes it picks out exactly the right line, sometimes it misses out and it gets confused and it tells you the wrong line, but then you have to search for the right one. So these are always caught. So these are generally easy to find and fix. Why? Because the translator will tell you that there are problems, and it helps you pinpoint those things, and it will not run it or compile it if you don't fix that error. And the other type of errors are called semantic errors, and these are the errors in the logic of the program, right? So you think you want to do something and you write the code and you think you have written the right code to do the right thing. The code is grammatically correct, syntaxes wise is correct, compiler or interpreter doesn't find any issues with that. It runs it, but when you run it, it doesn't do what you expected it to do. It does something else, right? That's when we call it logical errors, all right, or semantic errors. Harder to find and fix because the compiler doesn't help you with that. It can't. The compiler is only there to check the syntax. So we need debuggers for finding and fixing these type of errors. Okay, so that's what debuggers are used. Debuggers let you they let us step into the code, let us step over the code one statement at a time. They let us inspect the values of different variables, all right, and things like those. So we can so it becomes easier for us to find out, okay, where it is it bombing out, where is it crashing, where is it going wrong. So they're a very, very essential tool, all right. So all three, very, very important. Cannot develop, we need to have at least these three, if nothing else. At least these three are needed. So the most essential tools. Sometimes we can have additional tools like profiler. So there can be something else. Let me write down. Additional tools for program development, and the only additional tool that is generally needed is a profiler, and that sometimes generally you have to. It's another program that you have to use. So profiler, what it does is it let us evaluate the performance of different modules in our code, and in an attempt to improve them, basically. All right, so like you write a program, you run it, it's running fine, it's giving the right results and everything. So everything's perfect, except that you find, or the customer finds, that the program is running a bit too slow. It needs to be more efficient, more fast. It's processing the records not at the same rate that they're expecting. The user may have to wait for it. So it's not passing the performance test. It's not fast enough or efficient enough. In that case, you need to make it fast. And how do you do that? Well, not all, it could be a very big, huge program, and not all of the portions of it may need to be improved, because it takes time and money, and time is money. So it's expensive to go through the program and try to optimize every portion of it. And so there is a simple rule in programming that 20% of the code runs 80% of the time. Right? So it's called the 80-20 rule. The 80-20 rule. Right, so let's do that. So 20%, so 20% of the code runs 80% of the time. That means the performance is only given or determined by 20% of the code. I don't need to optimize 100% of the code. So all I need, so in that case, I need to know which 20% of the code I need to actually spend time on. And Profiler helps us do that. So it puts certain checkpoints in our code and it runs, and then we run our code, execute our code for a certain number of time, different use cases. And then the profiler basically tells us the statistics, which module was called, how many number of times, and so we know which portion is used more commonly, and then we go and we optimize that. All right, so it's used for code optimization. Used for code optimization. All right, and so these are some of these some of the tools that we need, and we call it. So we need to pick an IDE for that. All right, and so the IDE I'm gonna be using and installing is called the PyCharm IDE. So the PyCharm IDE. And so there are several different types of IDEs available for Python and for different languages. All right. So people often find Spider to be easier to use. All right. But I'm gonna today change that perspective, and we're gonna find that PyCharm is one of the more commonly used IDE than the Spider. Spider is not so good. So more professional Python programmers prefer PyCharm IDE. It's very nice. It's very good. All right. So we're gonna learn to use PyCharm, and all of the features that you have in Spider are available in PyCharm, and it's better than Spider. All right. So, but PyCharm is used by most professional Python programmers. All right, so I don't know. All right, so PyCharm is one of the more popular Python IDE. And so we're gonna be working with that, and you're gonna find it's very easy to use and much better than Spider.